So a warm greeting to all. In last video we have seen the classification of systems and followed by the linear and non-linear systems, and I have given four questions for practicing the linearity and non-linearity of a discrete time system. So with that, now we are going to discuss about another type of discrete time system, that is causal or non-causal system, and we'll see the conditions for checking the causal and non-causal system. If the system is causal, then we can say that the response of a system will be depend on the present and past inputs or only the present input. So it is going to depend on the present and future or only future, all it contains all states of input, then we can say that type of system as non-causal system. And to check the present, past and future conditions of a system, you have to substitute the value of t as 0, 1 or minus 1. And 0 is nothing but the present state, and if you are going to substitute the value of t as 1, it means that we are we are advancing the value of present value, that is we are advancing the value of 0 to 1, because 1 is greater than 0, so it means we are advancing the present state, so we are moving on to the future. So if you are going to substitute the value of t as 1, that is plus 1, we can say that state as a future state. Likewise, if you are going to substitute the value of t as minus 1, minus 1 is lesser than 0, it means we are reducing the value of present value. It means we are moving in the past state. It means we are delaying the present input, so we can say that state as a past state. So if you want to check the past condition, you have to substitute the value of t as minus 1, and for present you have to substitute the value of t as 0, and if you want to check the future state, and you have to substitute the value of t as plus 1. And now we'll see the examples for checking the causal and non-causal system. And this is the question that we are having, that y of t, that is response of a system, output is having x of t minus x of t minus 1. So the condition is you have to substitute the value of t as 0, 1 and minus 1. And if you are having the present, only present and past, the system is causal. And if you are getting future in a system, then obviously without any checking for the past or present, you can directly say the system as non-causal system. So okay, and with that introduction, we'll move on to the solution for this problem. Now we have to substitute the value of t as 0, that is for checking the present state. For y of 0, we are having x of 0 minus x of t is replaced as 0 and minus 1. So you can simplify this equation as x of 0 minus x of minus 1. So at last the present output is having present input as well as past input. So it is depends on the present output, depends on the present as well as past input. Now we'll check the response for t equal to 1. If you are going to substitute the value of t as 1, y of 1, that will be equal to x of 1 minus of x of the t value is 1. So 1 minus 1 is 0. So now for the present, now the present state is 1, and the present output is depends on the present input. So for y of 1 it is a present state, and for this condition we are having the present input and also past input. Okay, and now we can say for this second equation, it is also depends on the present as well as past input. Now we'll substitute the value of t as minus 1, and if you are going to substitute t as minus 1, the equation will be of y of minus 1 will be equal to x of minus 1 minus of x of minus 1 minus 1 will give minus 2. And now for this equation, the present state is minus 1, and for response at minus 1, we are having input at minus 1. So this response depends on the present input, and minus 2 is lesser than the minus 1. It means we are delaying the state, so it means it depends on past. So in all these three cases is having the present as well as the past input in the equation. So if the input side, the output depends on either only present or combination of past and present, we can say that type of system as a causal system. So here we are having past and present for all the three cases, so we can say this system as a causal system. Okay, and now we'll see next example, that is the problem is y of t is equal to x of t minus 2 into x of 3 minus t. Now we'll substitute the value of t as 0, and for this the equation will be y of 0, that is equal to x of 0 minus 2 times of x of 3 minus t. Here the value of t is 0, so we'll get x of 3, and for this equation the present state is 0, and for the present output we are having present input, so we are having present input for this state. And now we'll check this x of 3. X of 3 is greater than 0, so it means we are having advancement in this state, so we can say that as future. So the output depends on the present as well as future value. Okay, and now we'll substitute the value of t equal to 1. If you are going to substitute the value of t equal to 1, the equation will become x of 1 minus 2 times of x of 3 minus 1 will give 2, and for this equation the present state is 1, so we are having present input here, and x of 2, the 2 is greater than 1, so it means we are having advancement in this state, so it is having future input. And similarly you have to substitute the value of t as minus 1, so the y of minus 1 will be equal to x of minus 1 minus 2 times of 3 minus of minus 1, so minus of minus 1 will become plus 1. If you are going to add this with 3, we'll get 4. So for this equation the present state is minus 1, because we are having a y of minus 1, and for this state we are having a x of minus 1, so it depends on present input. And another input is x of 4. 4 is very much greater than minus 1. Okay, and minus 1 and then 0 and then 1, 2, 3, after that only we will be getting 4, so it is very much greater than minus 1, so obviously it is a advancement in the present state, so we can say it is a future. So if any of the state contains a future term without any discussion about the past, we can directly say the system is a non-causal system. Okay, and now these are the questions to check the system whether causal or non-causal, and solve these 4 questions by your